Okay, this is chapter 9. This is section 9-3. This is recording number 2. All right, so what I want to do is the example in the book is a little bit too tedious. I would never ask you to do those calculations on a exam. It's just too hard. I mean, you need to know how to do it, but I don't think it's worthwhile spending the hours that it would take to do the calculation. The reality in life is that it's all done by the computer. So it's important to know how it works, of course. So we're going to do a little bit of a shortcut here. So what I did was, give me 1 second here. This is the study guide that I sent out to you. Gosh, I hope I can get this organized here. Okay, so this is the study guide that I sent out to you, I believe. Let me double check that. Okay, yes, this is the study guide, and the reason I know that is because it has the answer key in the back, okay? All right, so on this study guide, I have a variety of problems. There won't be this many problems on the actual exam, but this just kind of covers all the material. So problem number 41, let's take a look at this. This is section 9-3. All right, so we have a sample of 46 students enrolled in a program that claims to improve scores on some sort of a test. So let's keep reading. The participants take a mock test, a practice test, before the program begins, and then at the end to measure their improvement. So I hope you see that this is an example of dependent subjects, right? The kids that score high in the before will probably score high in the end. Kids that score not so high might score better, but they will, not score. There'll be an improvement, but there's a matching. All right, so clearly it's dependent. I hope you see that. Okay, so it's not matched pairs like we talked about before, like John and Susie. It's just John and John. It's John before the review. He takes the class, or he takes the practice exam, and then afterwards he takes the practice exam. So he's the two data points that we're concerned about. What's his delta? Okay, so now I got this off of the website, excuse me, off of the publisher's software. I apologize for this, but it's not my fault. This is the publisher. The mean number of points improved was X bar equals 16. Well, that's not the notation that the author used in the book. In the textbook, the author used, D for all of these deltas, and then he used D bar to find the mean of the deltas. Okay. So he used D bar, all right? In the exam, he said X bar. So X bar is the mean of the differences, the mean of the deltas. Now, the way the problem says it is the mean number of points improved was X bar. Okay, so we're jumping the gun here saying that it improved. Okay, so assume the standard deviation is sigma is equal to 53. Now let's compare that to what he has in the book. Okay, and again, unfortunately, the notation is slightly different here. In the notation in the textbook, he's using S sub D is, where is that at? Okay, so in the book he says, find the standard deviation S sub D of the differences. So in the book he's saying S sub D. Okay, makes you crazy, okay? But that's just the way it is, okay? You see this all the time in the literature. The notation that people use is going to be a little bit different from one place to another. You just have to understand the concepts, and then you'll be okay. Okay, so give me 1 more second here. All right, so this is the information that you're given. Okay, we want to do this hypothesis test, and we want to check out the hypothesis. And the null hypothesis is that mu is equal to 0. Okay. In other words, the mu. What is the mu of? The mu is of the deltas. How much does it change? Well, if it's if mu is equal to 0, what they're saying is the mu of the deltas is 0. Okay, so that's the concept here. I know the notation is making you crazy, but if you understand the concepts, you can substitute in. And I'm going to show you the solution, and you'll see that's exactly what I did. Okay, and then the alternative hypothesis, the research hypothesis, is that no, the improvement, there was improvement. It was the before and after. The after subtract the before, the average of that delta is greater than 0. There was a positive improvement. Okay, so I sent you out a package of handwritten solutions. So here's number 41. This is the problem we're doing. And I want you to really carefully look at my solutions. I think that I am giving you good advice to tell you to do it this way. I have a standard way of doing it, and I demonstrate it in my solutions. So number 41 is improving student scores. This stuff here in the brackets, that's just to help me stay organized. I put it in here just to kind of like, and I would do this if I were a student as well, is just a little quick summary, 5 or 6 words. What is this problem all about? Well, what this problem is all about is testing the difference between two means with dependent samples. And over here, I write down what section is it from. I even write down what page number and what example numbers would be of help. So here's what we're given. This is the information we're given. I always have the same structure. I have a given, then find, and then I have a discussion or a dictionary, depending upon the problem. So given, students' sample size is 46, enroll in the tutoring. Each take the test before and after. X bar is equal to 16. Now, X bar, this symbol right here is a math symbol. It means defined. So X bar is defined as, we have, instead of having 2 little lines or 2 little segments, you have 3. That means it's defined. So X bar is defined as the mean number of points improved. So that was previously what we called our D bar. Okay, I'm sorry about I'm sorry for the difference. Okay, so what we're also given here is that we're going to assume that the null hypothesis is that the mu of the differences is 0. Before and after, the difference is 0. The research hypothesis is that it is greater than 0. There was an improvement. And then, see, this is what makes me crazy. The problem says sigma, but in the book it's S sub D equals 53. Now, the distinction is sigma is normally used for the standard deviation for the population. We would normally use S, okay, because that's the sample. We would normally use S. I don't know why the problem does it this way. It's either a typo or maybe the author is saying, oh, well, we're going to consider this to be the population. It doesn't matter. Everything stays the same. So find, compute the test statistic. That's all I want you to do is compute this test statistics. Okay, so first of all, here's my solution. We note that the sample data are dependent since high-scoring student will tend to score high both times. We are also only concerned about the gain or loss in values. We don't care what the scores are. All we care about is, did it go up or did it go down? So now here's my dictionary and formulas. We're going to use the t-test. Here's the formula right out of the book. Then I made a note to myself, hey, listen, the formula in the book has slightly different notation than in the problem, but I can handle it. I can handle it. D bar, that's the mean of the differences, or as stated in the problem, that's my X bar. That's the mean numbers of points improved. So, as I said before, it's so important. Be able to articulate exactly what's the random variable. The random variable is number of points improved. That's the random variable. So X bar or D bar is the differences of the scores. Okay, 1 second. Okay, so the original random variables are the scores, but now we're interested in a different random variable. The random variable we're interested in now are these deltas, the differences. So the D bar or the X bar is the mean number of points that you improve, and mean number of the mean differences, okay? So D bar, which is exactly the same as X bar, just the notation is different, is 16. That was given to us. The S sub D is 53, okay? The mu sub D is a population mean number of points improved. By the hypothesis, the expected value is 0. That's what we expect it to be, okay? and then n is 46. Okay, so we're going to compute the value of the test statistic. Here's the formula. Now we just plug everything in. The d bar, otherwise known as the x bar, is 16. The mu sub d, that's by the hypothesis, that's 0. S sub d, that's the 53. And like I said before, unfortunately, the author did change the notation a tiny bit here. He gave it to us as sigma, but we're adults. We can handle this. Okay, come down here. Okay, so all this, just calculate, and boom, you get an answer. So it's 2.05. And then in your study guide, that's answer D. Okay. Now what I did next though was I wanted to help us understand this, right? So let's go ahead and let's try to use this. So if the test statistic, sorry. And by the way, you know, sometimes they call it test statistics, sometimes they call it the test value. You know, it's the test value. The test value is what you get from the actual data that you are working with. But let's help us understand this. Let's just do it. Let's just do the problem. Okay, we'll make up a problem. A one-tailed test. Alpha is equal to 0.05. The degree of freedom is 45, since the number of people in the experiment was 46. I look up on my table and I get the critical value is 1.679. So in this case, we would reject the null hypothesis because the t value, the critical value, is 1.679, and the test value that we calculated was 2.05. That's over here in the reject region. Okay, so this is all in the email that I sent you. I hope it helps to help you understand this. Okay, so that's the kind of problem that you would be responsible for on the exam. Going back to the book and the example, I wouldn't give you a boatload of data like this and expect you to do all those calculations. It's just ridiculous. It's too hard. Okay, it's not that it's too hard. It's just too tedious. It just takes too much time. Okay, so the way the author suggests doing it, good. I hope you look at it. He always wants you to do these tables. I'll let you read the tables for yourself. The tables just keep you organized. You could put this on an Excel document and it would just do everything for you. Okay, right? So I hope that was some assistance to you. These aren't hard. It's just keeping track of what are the various things that we're dealing with. And when I say things, what I'm referring to is what is the original random variable. In the case the sample I sent out to you, the original random variable was the test scores. But we don't care about the test scores. What we care about are the delta test scores. So the new random variable that we're concerned about are the delta test scores. So that we calculate all those guys out, and that gives us an X bar. On the exam was X bar. In the book they called it D bar. Same idea. And from there we just do our calculations. The hardest part is understanding that the random variable is not the test scores themselves. The random variable is the delta test scores, the score before and after. Okay, so this is another concept here about the p-values. You get them from table F for two-tailed tests. You know, I'm gonna let you do that. It's always the same thing on these p-values. The concept behind the p-values is you figure out what the actual probability is for your result, and then you decide, do you reject or not reject based on that probability. And we've done that before.